Howdy. I made an observation today at our new place. The cooking oven is 3A. How funny. Yeah, I think that's really funny. I like cooking. But now, science news, the fastest science news app. Okay. Special Olympics, blah, blah, blah. And then the next one. A YouTuber explains if solar panels are worth it after using them for 4 years. A YouTuber. What does that mean? I don't click on that because just the title is very interesting. A YouTuber. As if it would be some kind of title, you know? Like people getting titles. Is being a YouTuber already this kind of title? Did it become such a thing? Really interesting. Science news. If you scroll down, you get NASA. You get whatever science news. Again, NASA. 1 hour ago, actually, this we could read. 1 hour ago, millions of tons of strange new chemical were discovered in Earth's atmosphere. Millions of tons. So, scientists have discovered that an ultra-reactive chemical in Earth's atmosphere lasts much longer than we previously believed. In fact, they believed that millions of tons of the chemical could linger in the atmosphere for several hours. This ultra-reactive chemical in the Earth's atmosphere may be cause for concern. The chemicals in question are hydrotrioxides. The chemical is made up of a hydrogen atom and 3 oxygen atoms. Perhaps the most concerning thing about how long these ultra-reactive chemicals last in the Earth's atmosphere, though, is the implications that they have for human health and the Earth's climate. Hydrotrioxides were previously believed to only linger for a very short time. Now, though, a new study suggests that really interesting. This never works. Really. Suggests they could linger in Earth's atmosphere for at least 20 minutes, maybe longer. And because it's a product of common chemical reactions, new amounts of the chemical are being generated almost constantly. Hence, it is the fluctuation of the electromagnetic circuit in which Earth is. So I have been explaining about the layers. And this is just my opinion, which isn't like, a real opinion because I'm no scientist. I'm not even a YouTuber. But I think it's because if that's Earth and we have all those layers, there are many of them. And if there's energy going through, which is going all the time, those layers, how to put it, they will differ in the distance or in the thickness of them. So if they are wobbling, there will be created different kind of charges and these kind of things. So the molecules and they get altered in real time. Because we are all connected all the time. We could maybe think about these like auroral phenomena. But anyway, let's continue reading. Further, this ultra-reactive chemical in the Earth's atmosphere can interact with other compounds extremely quickly. And because hydrotrioxides contain extra oxygen atoms, they could be extremely flammable. In fact, other peroxides have been used in rocket fuel tanks to their flammability. This isn't a new chemical reaction. Yeah. All chemical reactions are electrical in nature. It's ions changing places and these kind of things. Charge differentials and so on. It is important to note that it isn't a new chemical reaction. The study, which researchers published in the journal Science in late May, says this is just the first time we have found evidence for these chemicals in the atmosphere. But now that we know this ultra-reactive chemical is in the Earth's atmosphere, it does have some scientists wondering how it might affect our health. Why is this jumping all the time? Stop it. Scientists consider hydrotrioxide as ultra-reactive for a reason. Unlike some other chemicals, hydrotrioxide can interact with just about any other chemical out there. Really interesting. Further, almost all chemical reactions create hydrotrioxides. So it's really abundant, obviously. As such, the researchers... What's wrong with that? Why is this jumping all the time? Researchers estimate that at least 11 million tons of hydrotrioxides form in the atmosphere each year. Because this ultra-reactive chemical is so common in Earth's atmosphere, scientists believe it could play a key part in how the atmosphere works. Check it out! They found something. Which I think is... anyway, let's continue reading. What the part is, though, is unclear. To prove that kind of thing, scientists will need to look deeper into hydrotrioxides as a whole. While we don't have all those answers just yet, though it is always intriguing to see science confirming the existence of something within our world. Yes, the chemical itself might be not new, but its existence in our atmosphere is new knowledge. And now that we know, we can figure out what part it might play, and even if it plays a part in the atmospheres of other planets too. Oh, sorry. Wait a second, I got to search something. Yeah, I just searched now a video about Berkeley currents, weather, and I will put a link below to that. You really should watch the whole video, but I think it's really interesting that they are confirming these kind of things. But let's have just a listen. It's just somewhere now, this video. So.
And the workings of a typical Berkeley current. It's based on answering a very simple question. If we have a moving plasma cloud consisting of positive and negative ions, protons, electrons, and other particles such as neutral atoms, in otherwise completely empty space, and we leave it absolutely alone, we don't touch it, what shape, what structure, if any, will this stream attempt to take on? What forces will these moving charges impose on each other, and how will they respond? What will the result be? The derivation is a fairly complex one that involves some fancy vector calculus, but the structural shape that results is elegantly simple and testable. It turns out that the flow is essentially a cylindrical tube that contains plasma moving in coaxial spiral, that is helical paths. As we get farther away from the central axis of the flow, the pitch angles of those spiral pathways gradually increase. Now, this produces an intertwined internal structure that has several self-maintaining properties.
So you can watch the whole video, and I don't know if he's talking about diachron instabilities, but you could think of this like that. That's Earth. Oh, I missed. Let's try again. Earth, and this is the Berkeley current, which goes through Earth. North-South pole. Okay. And this thing here on the right is going up. So it's basically, it should be vertical. Okay. And it will create these diachron instabilities. And I will show you a similar like thing, like this diachotron instability on windy. So now let's see if it's visible. As you see, I'm loading the picture, so I don't know. It seems like that it's visible. So if you imagine the picture what you're looking at now is Eastern Europe, Russia, and Siberia, Scandinavia, Iceland, Greenland. Up here somewhere, it's not visible on this map, we have the Gackel Ridge, Laptev Seamount, where our magnetic North Pole is situated at the moment. And there's this Birkeland current which goes out there, and there's like energy flow in both directions. And this weather feature, what we have here, or maybe it's this one too, but no, I don't think so. Because this is coming from below and this is from above. So this is more attached to the thing in the north. So I think this is diachotron instability of Earth's northern Birkeland current. Maybe he explains it in the video, I don't know. I should watch the whole video once that I know what is going on in the video. But I just thought that I want to show you that that's this kind of proof for the claim that the universe is electric. The diachotron instability in the energy flow, electromagnetic current, which connects us to the sun and therefore to the universe, to the center of our galaxy, and so on. Life all the time. And we are just really, really, really small parts of this whole game. And I think it's really interesting because this goes really far south. This is Italy. Yeah, northern Italy, approximately. Anyway, interesting times. Thanks.